How do I join them? How do I join? How do I join? How do I get business membership?
Testing, 1, 2, 3. Yeah, I tried flipping it.
Still off? Oh, yes.
Good evening and a very warm welcome to our latest Tech Talks here at Mountain View. This is the final one of our winter series, and thank you those who are joining us on YouTube online now or via catch-up. A warm welcome to you too. A couple of items of housekeeping, please. First of all, would you make a note if you're using a hearing aid to switch to T mode? We have an induction loop here. You make sure that your mobile phones are either switched off or set to silent, please. And just a reminder that our fire exits are over at this door and to the rear where most of you will have entered. Our speaker this evening is a very recent, exciting recruit to our amazing AFD team, and with a surname like Comish, you'd expect him to have moved from Ballasalla or even Peel. That's not the case, as Josh, with his wife Rachel and young daughter Claire, came all the way from Utah in the US of A. Josh has led the development on various cloud-native platforms and has migrated over 20 individual applications from on-premises environments into the cloud. With a name like Comish, you realise that Josh's ancestry is from the island, and he is an admirer of everything Manx, and even speaks a bit of the language. He's a certified developer from Amazon Web Services and has acquired a master's degree in software engineering from the University of Texas at Austin, which is over there. So without further ado, can you give a very warm welcome to Josh, who's going to talk to us tonight about all things cloud. Josh.
Thank you, everybody. Does our sound good? Okay. All right, so I'm Joshua Comish, as introduced. Thank you for coming out tonight. I'm going to be talking about the cloud, AWS, what SaaS means, of all things, and hopefully you can learn something tonight. Oh, you know what? There's the clicker. All right, so a little bit about me. Thank you, David, for the introduction. I'll be repeating a little bit. I got my bachelor's degree from BYU, Idaho. That was in software engineering. Shortly after, I moved to San Antonio, Texas. Bit of a long trip, but we loved our time there, and a great place to get my career started. I joined on with a company called FutureX there, where I helped with cryptography and financial systems with them. Shortly after, I helped a couple of small companies, one of them being a startup, with their cloud migrations. I got started on my cloud experience with Sunloan, with a financial loan system for customer communication. And then I helped FloatMe, which is a very well-performing startup. I helped them readjust their infrastructure in the cloud to make more sense. Shortly after, I moved to LMI as a government consultant. They're pretty big. I was helping primarily with their automating their QA, moving a lot to the cloud, and project management. And while I was there, I worked a lot of late nights and got my master's degree in software engineering from the University of Texas at Austin. All right, so before I got started, I wanted to talk about a personal experience of mine. So when I was a young homeowner, we bought a house in Texas, and we were doing great, but a couple years after, we noticed some rust pooling on our water heater. Now, our water heaters in the States are a little different. They only power the water or heat the water. They don't provide cooling or heating or anything like that. So it wasn't quite as critical as it is here, but I looked at it and I said, you know what, that doesn't look too hard to replace. I don't want to pay a plumber $2,000 to replace it for me. I'm going to do it myself. there's only one input and two outputs, right? How hard can it be? It's very hard, just so you know. If it was just a standard installation, it would have been fine. But mine had a heat pump on the top, and I thus had to learn how to solder pipes to reach the side of the unit. And it took me all weekend to do. We had no water. We were taking showers with a ladle and a bucket. I wouldn't recommend it. So what I learned from this experience is when you're messing with vital infrastructure in your home or your business, you should consult somebody who knows what they're doing and not just think, I can do that. Those are famous last words. All right, so today we are going to talk about 4 things. First, what the cloud is. Second, what SaaS means. 3, the impact of cloud adoption. And 4, strategies to adopt cloud technologies. So hopefully by the end of this session, you'll have learned something about each of these. So to understand cloud computing, it helps to understand the history. So I'm just going to go over a very brief history. There's a lot of events that culminated to create the cloud as it is today. We're just doing a very high-level overview. So first, it really starts in 1967, as most computing things in history are. They started in the 60s. It started with IBM idealizing and creating something called virtualization. Now, to those that don't know what virtualization means, this is essentially having one computer and multiple people using it at the same time. That's really all it means. All right, next event in 1969, the ARPANET was created. This was a project from the U.S. Department of Defense. The purpose of it was to connect different research facilities across the nation. The United States is a very large country, so you can't just post something over and expect it to be there in a reasonable amount of time. So researchers in MIT had to connect with researchers in Stanford and California. And that's what this was for, connecting their networks together so they can communicate. It's the predecessor to the internet as we know it today. So, speaking of the internet, does anybody know when the World Wide Web, as it is known today, was created?
1992.
Very close, very close. Thank you. 1991. So that's when it was created. Now, the World Wide Web, when it was released to the public, was in 1993, so you're right in the middle. But it was created in 1991. In 1994, and I'm gonna put an asterisk next to this. This is the first reference I could find to the word cloud as it's used today. Most people will say that it was coined in 1996 with Compaq, but I did find an earlier reference to it from General Magic, which was an Apple spinoff. Right, and then 1994 as well, Amazon as a company launches, and you'll learn in a moment why that's important. But before we get there, I just want to talk a little bit about how the internet works. So let's say you, as a user, wants to search a image of your favorite meme. So you're going to go onto Google. Your browser is going to handle this for you, so you don't have to memorize an entire URL. And what's going to happen is it's going to be broken up, that request is going to be broken up into packets. That's going to be sent to a machine on the internet called a load balancer, generally, not always. And that load balancer is going to send it to a different server. That server is going to compute your request, so maybe they have a database in the back end, and they just do a lookup and then get your meme and then send it back. The actual processing happens on those servers. And then the load balancer will then take that, send it back to you, and your browser will return the response. Wow, such response. Doge is my favorite meme for those that don't know. So what we're talking about today is everything on that end. So this stuff is normally invisible to users. It's supposed to be that way, so it's nice and simple. But that's what we're talking about. All right, so there are generally classified 3 types of hosting. The first one we're going to talk about is on-prem hosting. And that's the, let me just go back. So what we're talking about is where those servers are located in this case. So on-prem means those servers are on your company site. And there's advantages and disadvantages to all of these. The biggest advantage to having it on-site, on-prem, is that you have complete control. You can do whatever you want with whatever you want. It's on you. Now, as it's on you, you also have to do it right, otherwise it's on you. Another advantage is you have no contracts, no subscription fees. That's great, but do keep in mind that you do still need to upgrade servers. So server cost, and those can be quite expensive. Additionally, since you're maintaining those servers, you're going to incur costs from labor to maintain those, make sure that they're still running smoothly. You also have uptime problems. That's because usually office spaces they don't have the same networking inputs and outputs as, say, a data center does. So that brings us to our next one, data center. So data centers are a great way to go. They've been the best practice for the last 20 years or so. The reason why you might want to go with a data center is they take care of your servers or rent out server space. They take care of them very well. For those that don't know, servers are delicate creatures. They need specific temperature requirements. They have specific humidity climates. You don't want it to be too humid. You don't want it to be too dry. It's bad in either direction. So it needs to be just perfect. In addition, you have power requirements. You have networking requirements. So the advantage to a data center is they take care of all of that. And what that results in is higher uptime. And usually you don't have to worry about your hardware. It's taken care of. So there's a lot of good reasons to go data center. Now, really the disadvantages of a data center is that it's rigid. So when you reserve resources or you reserve space in a rack in a data center, you're sort of locked in. And it's difficult to get that up and down, scale that up and down as needed. All right, so now we're going to talk about the cloud. So we're bringing it right back to Amazon. So in 2002, Amazon only used 10% of their server capacity. That was intentional because they just launched their retail website. They wanted to be sure that they had enough resources to handle those spikes in traffic. Now, what they decided to do with that remaining infrastructure in 2006 is build AWS. So, you know what, we're going to, instead of renting out server time, we're going to rent out server time instead of servers themselves, which was really the first cloud environment that we have as we know today. So the advantages of cloud are many. The core one being it is extremely flexible. So you can match your demand, your supply of servers with exactly what you need. That's really the core benefit. Another extremely good benefit is it's pay as you go. So you don't have to pay upfront for all these expensive servers. There are options to make it make it less expensive if you choose to do that. But you don't have to pay tons of money to get started. So it makes hosting a lot more accessible. There are some disadvantages. First of all, it's difficult to rent physical servers. If you have a specific requirement that you need a physical server for, which is very rare, I will add, it's just becoming a thing to be able to do that. And you also need a specialized skill set. It does look similar to data center hosting, and it is very similar, but it's easy to go in thinking you can do it, like installing a water heater. and it turns out there's more to it. So you really want to know, either hire somebody that knows it or consult with somebody that knows it. All right, so to sum that up, I just wanted to give a real world example. So let's say it's after holidays. We all put on a little weight during the holidays, and you want to get back in shape. So let's say you want to, instead of reserving a server like you would for cloud, you want to get a treadmill, get back in shape. So if you're doing an on-prem environment for your exercise equipment, you're going to buy that treadmill. You're going to store it in your house. So you're responsible for the space inside your house, how much space it takes. You're responsible for the power it takes. You're responsible for oiling the belt, replacing the belt on occasion, making sure that there is no error in your treadmill. And yeah, so you're responsible for all of that. But you can choose a really fancy treadmill or bike or whatever. That is all in your control. Now, a data center is like going to a gym. So you pay monthly for a membership, and you don't have to worry about any of that. Plus, you have more availability. Now you want to do a bike, maybe, or an elliptical. Maybe you want to get into some weightlifting. Those are much more accessible through a data center. Now, cloud is very similar to a data center. It looks the same. It feels the same. The only difference is really you pay as you go instead of you pay monthly. So let's say in February you might have dropped off to going to the gym for 2 hours a week or a month. Well, now you're not paying a whole month of time for something you don't use. You're just paying for the hour or two. So think of it as if the treadmill had one of those coin machines and said, okay, after 30 minutes, put in a pound or something like that. All right, and that gets down to what is called the usability curves. So on these graphs, we have two lines. The red line is your usage, your demand, and your blue line is your supply. It's your server capacity. So something you never want happening are these two lines to intersect. That means something is going wrong. So if your blue line crosses your red line, that means your server capacity is not sufficient for your demand. So you might have slowdowns, your server might crash. But what you also don't want is a significant distance between the two. That's if you have significantly more supply than you do demand, that's wasted resources, that's wasted money. So what you're trying to get to is something like this. You really want to hug that demand curve as tightly as possible, and that becomes more of a reality with cloud resources, where you can instantly spin something up and instantly spin something down. You don't have to talk to somebody to do that. All right, so we talked about Amazon, we talked about AWS launching. So next significant event, Google Docs was launched. I think that's something that most people are familiar with here. This was definitely one of the first commercially available, or even available to the public, SaaS products. It's not the first, but it was revolutionary for its day. It really demonstrated the strengths of working in the cloud. In 2009, cloud databases were introduced around this time frame. So the reason this is so significant is because before this, you could have your compute environment, or the servers that computed your requests. You can have those in the cloud, but you would have to have your databases on-prem. So you would have some cross traffic, and that's very, very bad. So at this point, clouds were more of an idea rather than a finished product, and that brought it much, much closer. In In 2010, Microsoft entered the game with Microsoft Azure, which is another huge cloud provider. Other providers like OpenStack, Google Cloud Platform started jumping on the bandwagon at this point. And then in 2011, hybrid clouds were introduced. And what that is in the cloud you can have a private area where only resources on that can communicate with each other. The public can't talk to it. Then you have your public area, and you can have them talk to each other. And now, once the hybrid clouds were introduced, then we had a real finished product with cloud that is production ready. All right, so that's it about what the cloud is. Now we'll talk about what SaaS means. So it's a lot simpler than you think, I promise. So SaaS stands for Software as a Service. And the definition is SaaS is centrally located software that is offered via a subscription. Now, by centrally hosted software, I mean pretty much anything on the web. So if it's on the web, publicly available, and you pay a monthly or annual subscription for it, it's generally considered a SaaS product. So, as an example, we have Microsoft Teams, and we have Google Docs as well. Those are very popular SaaS products. It's not working. There we go. Thank you. All right, so now that you understand what SaaS means, just discuss, we're going to take 2 minutes and discuss what some SaaS products are that we use in our daily lives, maybe some recommendations for each other, just to reinforce what that means. We will get that started now. Okay. And if you are online, feel free to just type in the chat, and Lindsay will take care of it. All right, we'll go ahead and close that up. So let's just discuss for a moment some SaaS products that we are very familiar with. John was very excited to share one.
Thanks. Netflix.
Yeah, that's a big one, right? Netflix, any of those streaming services, that is a SaaS product. Any other ideas?
Online banking.
Yep, exactly. That's a good example.
AFD Evolution.
There you go. Do we have anything on the chat online?
That was from
That was it?
That
All
was
right.
from Peter Denton in the US.
That is perfect. Yeah. All right. So some examples. We did get one of them that I had. So we have Slack. That's another one. Zoom. That's been very prevalent in our lives the last couple of years. and Netflix, as John pointed out. All right, so oh, that's interesting. There we go. I'm about to blow your minds. There is more to it than just SaaS. So SaaS is part of something called the shared responsibility model. And that's the sort of the easiest level if you're a user and subscribing to it. It's essentially saying, I want you to take care of this for me. We also have PaaS, Platform as a Service. We have IaaS, I don't know how to pronounce that, sorry. Some people say IaaS. That's Infrastructure as a Service. So a Platform as a Service, most won't be familiar with these products. These are products for mostly developers. So these provide hosting and software tools to speed up development and the hosting of those applications. So some examples of that is OpenShift, ServiceNow, AWS Lambda, AWS Elastic Beanstalk. They're providing you with a lot of the tools you need to run your applications. And then Infrastructure as a Service takes a step down. This provides compute, storage, and networking requirements to the user. So this is what cloud engineers are usually dealing with, Infrastructure as a Service. So some examples of this is AWS, Microsoft Azure, and Google Cloud Platform. Those are the three big providers. There are dozens of other providers. Those are the three big ones. So that takes us to a graphical representation of the shared responsibility model. So this is what it takes to run an application. These are the different sections of an application. The things on here, so anything in blue are things that you as the business or the provider are responsible for. And then anything in black are anything that you're paying somebody else to be responsible for. So as you can see, on-premise, you're responsible for everything, 100%. And the further right you go, the further into the cloud you go, you're paying somebody else to be responsible for each of these things, up to the point where you pay somebody to do everything except for your data. Now, as a cloud engineer, I will say that we generally regard anything in these three boxes as the cloud, and anything in these three boxes to be on-prem. So if you hear a cloud engineer talking about on-prem, they might mean on-prem at your business or on-prem in a data center. That's just a little bit of a quirk in our vocabulary. All right, so now that we know what the cloud is, what SaaS means, how it relates to the cloud, let's talk about why you might want to migrate to the cloud as a business, why it's important. So to do this, I think it's best to have some examples in your mind of users. So we'll talk about two characters here. Harry, who is a startup owner. He just launched his startup with his little bit of money that he has. He's really hoping it'll launch. So what's important to him is he's very, very cost averse. This is his own money, and it's very limited. So he needs to use his money very, very efficiently. He's interested in being able to build things very quickly so that he can build his product. And he is hoping for, if he's doing his job well, he's hoping for dramatic changes in demand. So he needs to be able to scale up and down very, very rapidly. On the other hand, we have Sally, who is an enterprise IT manager. So she has an existing pool of customers that are using the service, and they rely on that service. So she is very downtime averse. She does not want any downtime. She doesn't want a single customer to experience that. And she's looking to cut costs, and she wants to simplify the vast infrastructure that her team manages. So while we're talking about advantages, I'm going to refer back to those two people. So there's generally four categories of advantages for cloud. If you can look it up, and there's tons of them, but they all generally fall under 4 categories. First one is improved efficiency. So the biggest feature here of the cloud that helps it be more efficient is that the instances, the servers, they're on demand. So you can queue them up whenever you need, you can reserve them, you can do whatever you want with them. It's however you want to choose. So this is going to be particularly important to Harry as a startup owner, because he needs to be able to reserve those resources very, very rapidly. He doesn't want to be waiting for a response back from a data center, and he wants to only use the resources as he's using them. Additionally, it's easier to build proofs of concept because of this, because you can immediately request a server and have that in a matter of minutes. You can actually write code. This is called infrastructure as code. You can write code to spin up entire environments. This is going to be really important for Sally, who's looking to simplify and streamline. You can have a setup that manually might take you hours or days or even weeks to build. If you codify it into infrastructure as code, it could take minutes, maybe an hour or two to deploy instead. A very, very efficient way. And I will note that a lot of on-prem installations do have this available now through things, through products called like vSphere, with VMware. There's other ones. And they've caught up on that point. All right, the next one is data protection. So again, we're pushing our responsibility of the database to someone else. In this case, you have the choice to do that or not with the cloud. But if you do, your databases are automatically maintained. So operating system upgrades, database upgrades, security upgrades, that's all taken care of for you. So it's safer. They're automatically backed up, and you can choose the cadence that happens. And the most important thing are those backups are stored safely and reliably. So as cloud engineers, you'll hear the word 9 used a lot, the amount of 9s. This refers to how much uptime it has. When it comes to storage backups, you'll hear 5 to 9 nines, so 99.99999. And that's how secure it is, which is a very important thing if you have your backups, your database backed up on those hard drives. All right, so the next one is cost savings. I will just add, it was very difficult to find one with a pound that worked with my motif. It was all US dollars. So, of course, this is going to be extremely important to both Harry and Sally in this case. You pay only for what you use. So if we go back to that chart, we want to avoid that those wasted resources where with the cloud environment, you can really hug that line a lot better and a lot easier. All right, it's also highly competitive, so you have a lot of providers in the cloud. I mean, the big ones, again, are AWS, Azure, and Google Cloud Platform, but you have dozens of other ones providing dozens of different services. So, as such, the rates are very competitive. You also have additional tools to help decrease spending. My favorite tool is just a script that I have that'll automatically turn down servers when they're not being used in the nighttime, which can potentially save you 50% on your server spend. All right, and the last benefit is security. So this wasn't always a benefit of the cloud. Like I said, in the early stages of the cloud, it was an unfinished product, and it kind of got a bad rap during those days. They've since then fixed the problems. So now you have the ability to create private networks. So it will mirror exactly how a network behaves on-prem. And if you choose to use infrastructure as code, which I beg you, if you're going to do cloud, use infrastructure as code. That code will act as documentation, so you can see exactly when something changed to your infrastructure and figure out what caused that. You have a good paper trail. And finally, AWS data centers are secure and they provide redundancy. So if you're hosting on a data center, then you generally have one data center. If that data center goes down, which is a rare event, but if it does go down, you're completely done, at least until it comes back up. On the cloud, usually by default, your applications are running in multiple data centers at the same time. So if one data center goes down in London and you have another application running in Dublin, you're going to be fine. So that's an important security feature. All right, so those are the four core benefits of the cloud and why you might consider moving to the cloud. Really, for me, it's mostly improved efficiency and cost savings. It can be a lot cheaper. And as someone who maintains these things, it is a lot easier to take care of it. So I wanted to go through a demo. Now what I'm going to do in this demo, first I'm going to talk about if you're starting an application, if you want to build a server with your application on it in a data center, how long is it going to take? What are the steps you're going to need to do? And then I recorded a video of myself doing this in a cloud environment. So if you're going to do this in a data center, you have 8 or 9 different steps. So first you have to commission a machine, install an operating system, set up a network, install and configure the web server, configure SSL certificates, and many more. It's not important that you know these things, but just to demonstrate how much goes into it, that's what the list is. Generally this will take 2 to 4 days, possibly more, depending on your situation. So it can be an expensive venture to deploy something to the cloud the first time. Now, what I'm going to be demonstrating here is how I often do this in the cloud. So I wrote some code and I deployed the server live. So it's going to take about 2 minutes and 15 seconds to do. Right, there we go. Now, while this is going, I will note that I cheated a little bit here. This is a platform as a service, not necessarily an infrastructure as a service. So a lot of things are being provided to me. I'm having AWS handle more of the shared responsibility than I normally would. So what I've done here is I've written hello from AWS. So anything that talks to the server is just going to respond back with hello from AWS. And that's going to be from an AWS server. So the first file was the actual web application that's being run. And this file is defining how we're going to deploy that in the cloud. And that's all that is. Now, another note while this is going, I did have to create an AWS account for this. That takes about 10 minutes, and then configure it on my machine. All in all, about 15 minutes, but I wasn't going to obviously record that and do a 17-minute video. But if you have everything set up, it's very easy to do. All right, so I just typed in one command to deploy the code. You'll see that it's already going pretty quick. And it's deploying this to a Lambda environment, which is something called serverless. I can do a whole nother tech talk on what serverless means, because that is another misunderstood term, much like cloud. And it's in just a second here, we'll have a link. So now that code in main.py is deployed to AWS. Again, took 2 minutes and 15 seconds as opposed to 2 to 4 days. If we go to it, it says hello from AWS. So it's that easy to do it in the cloud. I'll stress that this isn't the only way to do it in the cloud. You do have infrastructure as a service available, which will feel much more familiar to people from a data center environment. But this is the way I prefer doing it because it's so easy. All right, and we'll just talk about just for a minute about some case studies. So you're not just hearing it from me, but hearing it from people who have benefited from cloud migration. So first we'll have A Cloud Guru. This is one of my favorite examples. So A Cloud Guru, what they do is they train people like me. So they have online videos and training courses to train people for cloud certifications, specifically cloud certifications, so whether that be on AWS or Microsoft or whatever. So they've recently launched, and within 6 months, they scaled up to 40,000 users. Something to stress in these 6 months that I love is they didn't pay a penny for their compute environment. They only paid for storage and retrieval of those videos, which is absolutely incredible. So they made over $1 million in revenue before they paid anything for their actual servers, which it just warms my heart. Currently, they handle over 7 million requests per day, and they pay less than $10,000 a month. And that includes all the storage of their vast collection of videos. That includes their database, their compute environment, everything they have is hosted in the cloud, and they're able to do all of that for less than $10,000 a month, which is absolutely incredible. All right, next one is a company called Brainly. So they migrated from an on-prem environment to AWS, which is probably the more common case. So they had over 100 on-prem servers that they needed to migrate. When they did, they reached an uptime of 99.98%. Now that is very good for an actual application. That just means 99.98% of the time their servers are up and ready to communicate with the world. Perhaps more importantly, they cut operational costs by 50%. So it's found that when companies are moving from a data center to the cloud, they'll often save around 30 to 50%, 30 to 40 generally, they save 50. And that's because they hug that demand curve a lot tighter than what you might find in a data center. My favorite quote from them is their IT team of 4 was doing the work of 25, because they're coming from an on-prem environment with 100 on-prem servers. That's a lot of work, and because everything was automated and centralized, easy, their team of 4 was able to handle that on their own. All right, so now we're going to talk about some migration strategies, just very, very briefly. This is another very deep topic, but we're just going to barely scratch the surface on it. If you do have any questions about migrating to the cloud, please let me know, and I can help you out with my experience. First one is rehosting. So this is what most people think about when they're migrating to the cloud. This is what they call lift and shift. So take your application from an on-prem server and move it to a cloud environment. This is very difficult to do. I generally don't recommend it because the conditions are a little bit different in the cloud. So you need to be really careful when doing this that you don't break something. Next one is replatforming. This is generally what I'll recommend. This is also known as lift, tinker, and shift. So this is where you tinker your application in places to use cloud technologies before you migrate it, and then you migrate it. It's just a lot safer to do it this way, a lot more stable. You're going to have less problems if you replatform rather than rehost. The next common method is repurchase. So maybe there's something that you are building or maintaining that there's a effective SaaS product out there available now, and maybe it's cheaper to pay for it than it is to maintain it. So that's another option. Refactoring. Now this, I don't generally recommend this, but sometimes if the code is so bad, I might. So this is where you just scrap everything and you rebuild natively in the cloud. Generally not a good strategy, but if you do, maybe if you don't have much of your original staff that wrote the code, maybe it's a good option, but it is an option. Next one is retiring. So maybe there are things when you're working on a migration strategy that you found not very many people use. maybe it's time to retire it while you're doing your migration. Save some work on the actual migration and save some work while in the maintenance down the road. And the last one is retain. Maybe you have some resources that it's not practical to move it to the cloud. That's fine. You can keep it on-prem, and you can have it communicate with your resources on the cloud. It's very possible, very practical, done pretty often. So. All right, so that's all I have. Hopefully you have learned something about the cloud today. And I believe I'm handing it back to David at this point.
No, you're going to answer. For those who are watching online in real time, not on catch-up, you can use the chat feature on YouTube. We have a YouTube browser in the room, but if you speak slowly and clearly with any question, the room mics should pick that up. Otherwise, Lindsay will call out anything online. But Josh, it's back over to you yet again. Thank you.
Are you sure you don't want to take care of this? All right, so questions, please.
You said right at the beginning that one of the advantages of having an on-site server was that you were in control. But the presentation you've just done gives the impression that cloud is wonderful and that there aren't really any big disadvantages. So haven't you lost a bit of control? Aren't you vulnerable to these big companies doing the dirty on you in some way, or leaking your information, or being careless with it, or hiking their prices up? You know, aren't there still some advantages of having on-site servers?
Oh yeah, there's definitely advantages. I would never say that it's never a good idea, right? Now, this gets back to the shared responsibility model that we showed with the 6 different environments. So when you are in the cloud, perhaps building everything from scratch, there are still things that you are responsible for. You're paying AWS or Microsoft to be responsible for the other things, and they do a very, very good job at it, better than what most companies are able to provide. But you are still responsible for a lot. There have been cases where companies didn't understand that model, and they configured something in the wrong way, and they leaked data. Now, AWS in particular has been doing a very good job at locking that down by default, and quite frankly, making it difficult to do things because they don't want people making those mistakes. So they are actively making things more secure and more error-proof, but you do still share responsibility. I will say the things that they're responsible for, I haven't seen a single case where they broke because of what they were doing instead of because of something that's
So can I ask why doesn't AFD get rid of all of its on-premises servers and just go straight to the cloud?
Yeah, that's a good question. So, I mean, there are some databases that, for example, we have that might be, it makes more sense to have it on-prem because the way things are set up. So, for example, our address database, our installed applications in our environment are here in the environment. So, you may just want to leave address where it is and migrate other things away. But that's a strategy we need to figure out as we go. That's all part of the migration.
Okay, does anybody else have any questions in the room? Okay, we've got one from online, Josh, and it's saying, for a typical business, are there any services that you think are better hosted on-prem?
They're hosted on-prem, right, services.
Can you just
Generally,
review that because you're
generally, better, something that's better hosted on-prem. So usually if it's better hosted on-prem, there's a specific requirement that it's hosted on-prem. So maybe you have a customer that does not like the cloud. Maybe they've had a bad experience with it where they have had data leaked because somebody, like a SaaS provider, was mishandling their data. And that would probably be the best example of a case where on-prem is better than cloud. Other cases are where you have very, very sensitive data that, so for example, intelligence networks and such, they'll generally be hosted on-prem. The cloud has been offering services for those, and they have been adopting those, but generally if there's a better reason to do it for on-prem, it usually means because there's a specific requirement for it.
Is there anybody else in the room? Can I have this mic up, please? Thank you.
Hi Josh, is this on? Hello?
Can I have the other handheld on, please? There we go.
There you go. Thanks Josh. My question is about data protection. So on-premises versus the cloud. So if all my data, all my corporate data is on-premises, I've kind of ring-fenced it in my head and hopefully physically as well, so I know it's safe. So if I migrate to the cloud, I'm kind of intermingling my data with lots of other corporations' data, and so that makes me uncomfortable. So how can I get in my head to be more comfortable about having my data mingling with all that other data?
Yeah, that's a great question. So generally, when it comes to the private data or KYC data, anything like that, you want it to be in the same environment wherever your compute is for those same reasons. Now, there are offerings provided. I know specifically of AWS where you can connect your networks directly to their network. You can essentially just reserve an Ethernet port that only belongs to you. So that really, really helps in furthering that data protection. So that's something you could look into. It's called AWS Direct Connect. Very, very good service. It's really not too different from how data centers provide their services with, they rent out server space essentially as well through virtualization. So the paradigm really is very similar.
Okay, thanks.
Thanks. Is there anybody else in the room who would like to ask a question?
A real spanner in the works in this whole strategy has been brought into highlight, perhaps over the last year or two, and that would be deplatforming, where a large corporation who is in control of your infrastructure suddenly takes a dislike to you or what you stand for or what you do. Sort of cancel culture from the big tech companies. And whether that's an opinion that you've expressed or a strategy that your business is running in, or even the ethics of your business or culture. Because when a large organisation which is carrying 100% of your business ability to deliver suddenly decides they don't want you, it's a bit like cancelling your bank account, which isn't, was once unthinkable, but now we look at Canada and see that in a stroke, Trudeau stopped people accessing their money. But you could see that paralleled. Amazon decide that they don't like you or what you stand for. How do you protect against that in your business continuity strategy? That's a big one for you.
Yeah, great question. So there are technologies available where you can, specifically infrastructure as code, and this works on cloud environments, this works on on-prem environments as well, depending on your setup. And the strength of that is that you can set up your infrastructure in code, and you can deploy that anywhere. So you can deploy, if AWS decides we're not going to host your services anymore, you can have everything in place ready to go to Microsoft. Or you can have an on-prem environment ready where you can deploy it there. So that's another reason why I say infrastructure as code is essential, so that you can prevent from things like that happening. And also if AWS decides, oh, I'm going to jack up my prices, well then you have a chance, you have an exit, you're not locked in.
So the supplementary to that is how easy is it to port code between the different players in the market or your own infrastructure?
Yes, so it depends on the technology that you use. There are services that they've essentially defined their own templating language that operates, that's perfectly interoperable between different cloud platforms. Those are going to be really with the big cloud platforms. And really, if you're deplatformed from one, you're going to be deplatformed from multiple, right? So that's why I prefer they stick to the tools where you do require a little bit of separate code to manage something for on-prem as well.
Brilliant. Well, thank you, Josh. This is a bit of a journey for AFD. We drew attention in the early slides there that the business predates the internet by at least 7 years. There's not many of those around there. So thank you for all the hard work you put into the presentation and for opening our eyes to it. Thank you to the tech team for helping with the delivery of the event, and to the properties team for the room, and of course to Lindsay for all the scurrying around organising and promoting the event. I'm sure you've all enjoyed it. For those who registered by Eventbrite, there'll be a short feedback survey winging to you. It would be really helpful if you could take a moment to complete it. And this presentation, as I said earlier, brings Series 3 of our Tech Talks to a close for now. The plan is to return in the autumn with some new speakers, so please give some thought to any subjects you'd like us to see covered, and we'll do our very best to seek appropriate speakers for that. If you've enjoyed this evening and you'd like to see more of our Tech Talks, you can subscribe to our YouTube channel. Just search Mountain View Innovation Centre, where you'll find a library of our past presentations. Thank you again for joining us. Have a safe journey home, and don't forget to switch your phone back on. Thank you, Josh. Yes.
Yeah.